Alright, today we're going to be going over Lagrange multipliers and how to solve them. So to start, we're going to go over what a Lagrange multiplier is and what they do. So a Lagrange multiplier is a way to find a minimum and maximum values of some function f with a constraint of the function g equaling to k. So the first thing you'll want to do is you're going to set the gradient of f equal to lambda multiplied by the gradient of g and set g equal to k. And then what you're going to do is you're going to set them equal to each other and solve for your point. So our first example is we'll have f of x equaling to x squared plus y squared, and we're going to have a g of x equaling to x plus y equaling to 1. So the first thing we want to do in these kind of questions is find all the partial derivatives of f and g, which is what makes up the gradient. So we're going to have f of x equaling to 2x, f of y equaling to 2y, g of x equaling to 1, and g of y equaling to 1. Now this will give us the gradient of f of x, which is 2x, equaling to lambda times g of x, which gives us 1. And then we'll have f of y, which is 2y, equaling to lambda multiplied by 1. And then finally, we're going to want to write our constraint of x plus y is equal to 1. And if you want to write this out, our gradient of f is equal to 2x and 2y. And we're setting this equal to the gradient of g, which is equaling to 1 and 1. So now in Lagrange multipliers, what you want to do is you want to find a way to set our two equations equal to each other. So having our top equation equaling to our second equation, which for this example is quite easy because we get to set 2x is equal to 2y, because as you can see they both equal lambda, which means that we can set the equations equal to each other. So now all we have to do is solve for x and y. And as you see, we can divide both sides by 2, which would get rid of both 2's, meaning that we're going to have x is equal to y. Now, once we have this point, we're going to want to apply it into our constraint, which means that we're going to have x plus y is equal to 1, and we're going to want to put this in. Now, since x and y are equal to each other, we can just make this x plus x is equal to 1. So 2x is equal to 1, giving us x is 1/2. And now if we put this new x value back into the constraint, we're going to solve for y. So this will become 1/2 plus y is equal to 1. And then y is going to be equal to 1 minus 1/2, which means y is also 1/2. And if you test it in your constraint, you'll get 1/2 plus 1/2 is equal to 1, so we know that this is our first point of 1/2 and 1/2. Now, if we don't get any other points based off of setting our equations equally to each other, this means that all we have to do now is test our endpoints. So our first endpoint we're going to check is by setting x equal to 0. So if we set x equal to 0, we're just going to get y is equal to 1 and x is equal to 0. So our first point is 0, 1. And then our same thing, we're going to set x equal to 1 and y equal to 0. So we get 1, 0, which gives us the 3 points of 1/2, 1/2, 0, 1, and 1, 0. Now, the whole part of Lagrange multipliers is to test for our min and max values. So now the way to do this is we plug our point back into our original f function, and whatever point is the largest value is the maximum, and whichever point is the lowest value is our minimum. So if I write a little box up here, we're going to test f at 1/2 and 1/2, which gets us 1/2 squared plus 1/2 squared, which will give us 1/4 plus 1/4, which gives us 2/4, which gives us 1/2. Now our point f of 0, 1 gets us 0 squared plus 1 squared, giving us the value of 1. And same thing for the f of 1, 0 gets us 1 squared plus 0 squared, which gives us 1. Which means that our maximum points, since the values are the highest, are going to be at 0, 1, and 1, 0, which means our maximum is at our endpoints, and our minimum is going to be at the point 1/2, 1/2. Okay, now our second question is the function f, which is 2x squared plus 6y squared, and our constraint of g is x to the 4 plus 3y to the 4 is equal to 1. Now we're going to do the same step as before. We're going to find our partial of f of y and f of x, which will give us 4x, and this will give us 12y. And then we want to find our g of x and our g of y, which will give us 4x cubed, and this will give us 12y cubed. Now we're going to take these and set them equal to each other. So we're going to have 4x is equal to lambda 4x cubed, and we're going to have 12y is equal to lambda 12y cubed. And then we're going to set our constraint as x to the 4 plus 3y to the 4 is equal to 1. Now we want to find a way to set these equations equal to each other. So the easiest way to set these equal to each other is by making our 4x equaling 12xy. So we're going to multiply our top row by 3 and y, which will get us lambda times 12x cubed y and 12xy, because we're going to just multiply our second row by x. This will get us lambda 12y cubed times x. Now what we're able to do is, since our left side is the exact same, we can set the right side of the equation equal to each other. So this will be lambda 12x cubed y is equal to lambda 12y cubed x. Now this will give us, if we divide both sides by lambda and 12, this will just give us x cubed y is equal to y cubed x. Now, since both sides have an x and a y, we can divide both sides by an x and a y just to clean it up a little bit better, because this will get rid of those, and this will become x squared is equal to y squared. Now if we take the square root of both sides, this will give us x is equal to y. X is equal to y. Now, we can't just stop here. We still have to find the points. So now what we need to do is we need to take x equaling to y and put it back into the constraint. So I'll put it over here, and I'll put it in blue for finding the constraint. So we're going to have x to the 4 plus 3, and since x and y are equal to each other, we can just replace it with x to the 4 is equal to 1. So this will become 4x to the 4 is equal to 1, which means x will be equal to 1/4, and is going to be the fourth root of 4/1. And now we put this back into our original constraint just to find our y. So we're going to have the fourth root of 1/4, but that's all going to be to the power of 4, plus 3y to the 4 is equal to 1. Now these will cancel, so we get 1/4 plus 3y to the 4 is equal to 1, which will give us 3y to the 4 is equal to 1 minus 1/4, which is 3/4. Now divide both sides by 3, which will give us 3/12. So y is going to be equal to the 4th root of 3/12, which is equal to the 4th root of, so we get the point of the 4th root of 1/4 and the 4th root of 1/4. So that's when we put our point x, y into the constraint. And since we don't get anything but x equal to y, there's no quadratic or anything, we know that we'll have both plus and minus of these equations due to the square root. Now, since that's done, we want to try to test it at our endpoint. So I'll draw a line again, and we're going to test them. We're going to test for our endpoints. So this will be setting x equal to 0. So this will become 3y to the 4th is equal to 1. So we're going to get y is the 4th root of 1/3. And then it's going to be plus or minus. And then when we set y equal to 0, we get just x is equal to the 4th root of 1, which is just equal to plus or minus 1. We will have the first point of the positive x of the 4th root of 1/4 and the positive 4th root of 1/4 for y. And then we will have the negative x of the 4th root of 1/4 and the positive 4th root of 1/4 for y. Then it will be the positive x of the 4th root of 1/4 and then negative y. And then we will have both of them being negative. And if you felt like simplifying it a little bit more, so that we get the root of 1/2 and the root of 1/2, and then the negative 1/2, negative root 1/2, and the root of 1/2, the root of 1/2, and the negative root of 1/2, and then the negative root of both of them, 1/2. There. And then that gets rid of our point. And now we have to write our endpoints, which will be 0 and 4 root of 1/3, which you cannot simplify anymore. And we'll get 0 and the negative 4th root of 1/3. And now finally, we will have 1 and 0 and negative 1 and 0. Now to find the maximum and minimum, what you'll have to do is plug all these into our original equation to see which ones is going to be your max and which one's going to be your min. But to save some time, all you have to do is test one of these points where we have the positive or the negative, because if you see, our x and y are both to the power of 2, meaning it would cancel the negative anyway. So to finish up this question, we will test our points. So we'll have f of plus or minus 1/2, and plus or minus 1/2 because it doesn't matter with it being squared, which will give us 4. Our f of 0 and the 4th root of 1/3, which will give us 6 times the root of 1/3. And finally, we'll have f of plus or minus 1 and 0, which gives us 2, which says that this will be our maximum and 2 will be our minimum.